So let's say you want to become a developer in 2024 and you have been told you can learn everything it takes in a few weeks. Well, take it easy because I have not very good news. Here's the thing. Rushing through a developer career right now is very tough. There is so much going on in tech right now, but still, you could be tempted to believe that it is easy just because it used to be easy like a decade ago. And there are, of course, channels promising shortcuts to get your first job as a developer. Something common I have noticed is that most of them give the impression that learning to code have never been easier. It is a bit like trying to become a chef by reading recipes. You might know what the ingredients are, but mastering the craft, that really takes a lot of time. Have you ever wondered why so many courses or bootcamps claim you can learn Java in a few weeks or become a C++ expert in a month? Think about it. Can you really become an expert in something so complex that quickly? We will uncover today the truth behind those promises, why learning software development isn't a sprint, and how real mastery is measured in years, not weeks and months. I have spent days reflecting on this matter before making this video. I will try to distill the essence of what really takes to become a great developer. And by the end of this video, you will know exactly what to focus on and how to approach your learning journey the right way. Ready to invest in your future as a developer? So let's dive in. Let's start with the elephant in the room. Why is everyone in such a rush to learn to code? It is almost as if everyone believes that software development can be squeezed into a few coffee-filled weeks. But can it really be? Here's the truth. You are not going to become a developer overnight, just because no one can. In fact, trying to speed through software development can do more harm than good. It is like trying to build a house by skipping the foundation. I mean, sure, you might have walls up quickly, but the whole thing is going to collapse as soon as a storm hits. And recruiters and hiring managers know this very well. Now, don't get me wrong, I get why those courses still sell the idea. Who wouldn't want to master a skill like software development in just a few days? Of course. But I have learned from experience that this is a craft that takes time. If you want to fast track your way to success, it is better to reset those expectations. I would recommend you to stop focusing on learning fast and instead focus on learning deeply. Take your time to understand the core concepts, and trust me, the rewards will be far more satisfying. Like for example, take the hash table, often seen as a simple data structure where a hash function quickly finds the value for a given key. It seems like an efficient and almost magical solution at first, but a deeper understanding reveals complexities like handle collisions, choosing between chaining or open addressing, and navigating real-world constraints like memory limits and load factors. Mastering a hash table is not about just knowing how it works on the surface. It is about understanding the trade-off and nuances that come with different implementations and learning when it is the right tool for the job. And this is something that only comes with experience and deep exploration of the other possibilities. But let's assume that you have a very short time to learn something. So the question is, what can we actually learn if we had only, let's say, 24 hours? If you spend 24 hours learning C++, for example, then sure, find up some syntax, you will probably understand what a for loop does, maybe even write a basic program or two. But knowing the syntax is not the same as knowing the language. Like when I started learning a few chords on a guitar, I could technically strum along a few basic songs, but was I really playing music? Well, not quite. It is exactly the same in software development. Syntax is the equivalent of learning those new chords. We will be still far from composing a symphony. But anyway, let's say you are coming from a software development background. I mean that you already know how to code, and decide to spend 24 hours learning C++. What you will probably end up doing is writing basic C++ programs. And the problem is that you won't really get what C++ is good for, and more importantly, what it is not good for. But does this matter? Well, it really does, because real software development isn't just about writing code. It is about problem solving, design, and thinking in the paradigms of the different languages, and making conscious decisions all the time about the design and the architecture of our applications. And that obviously takes a lot of time and experience to master. If you are serious about learning a programming language, I recommend you to spend time not just on the syntax, but also on understanding the technologies around the language, its philosophy, and how it is meant to solve real-world problems. Let me give you just an example. Consider memory management in Java. On the surface, it seems simple, right? Java has an automatic garbage collector, so you don't have to worry about memory leaks or manual cleanup, right? But as you dive deeper, you realize that understanding Java's memory model is crucial for writing efficient and performant applications. For instance, mismanaging object references, especially in long-running applications, can lead to memory leaks through, like, for example, unintended object retention in the heap, even with garbage collection. So knowing when to break circular references becomes critical in certain situations. And this means that mastering Java objects is not just about trusting the garbage collector. It is about understanding how memory is allocated, when objects are suitable for collection, and designing your applications in a way that avoids unnecessary memory bloat or performance bottlenecks. This level of understanding of Java comes with time and hands-on experience using the language. But for some reason, there is still a perception that it is possible to take shortcuts and learn all these things very, very fast. So now let me talk about the myth that surrounds the concept of instant expertise. Malcolm Gladwell made the 1000 hours rule famous in his book titled Outliers. As he tells it, the rule goes like this. It takes 10,000 hours of intense practice to achieve mastery of complex skills and materials, like playing the violin or getting as good as Bill Gates at computer programming. But he is not the only one who has noticed that real mastery takes time. Think about it. Mozart didn't start composing world-class music at the age of 4, even though he was considered a gifted guy. It took him years of practice to get there. And the same goes for the Beatles, who played countless gigs before their big break. And indeed, if you study the immense majority of people who have accomplished great achievement, it is evident that they spend a lot of time working hard to master their craft before becoming famous. It is just that we usually only meet these people when they are already at the top of the podium. So software development is not different. You cannot expect to reach mastery after a few weeks or even months of coding. It is a journey. And put it in simple terms, the more time you invest in it, the better you will get. So don't measure your progress in hours or days. Instead, look at your journey in terms of projects and challenges that you overcome. And the more you push yourself with difficult tasks, the faster you will grow. For example, in your first year of software development, you may feel like you are constantly entering a cycle of uncertainty about your own capacity, like debugging more than coding, struggling with complex concepts like design patterns or scalability. But after a decade or so doing the job, you will be amazed at what you have accomplished, like building complex systems, solving edge cases, and developing an intuition for problems that no tutorial could teach. Mastery in programming is a slow accumulation of experience and insight, gained over many years of facing real-world challenges. I like one quote from Bill Gates about this, when he said, "Most people overestimate what they can do in 1 year and underestimate what they can do in 10 years. So spending time doing the thing is enough in more cases, but unfortunately, not always. You have probably heard the phrase practice makes perfect. Well, in software development, it is more like deliberate practice makes progress. It's not just about doing something over and over again. It is about pushing yourself just beyond your comfort zone. It is like weightlifting. If you keep lifting the same weight every day, you are not going to get stronger. But if you gradually increase the weight, you will build muscle. Software development is exactly the same. Like for example, let's say that you are learning algorithms. Sure, you can solve basic problems, but if you never tackle something harder, like implementing a sorting algorithm from scratch, you are not going to improve. You need to challenge yourself, fail, and learn from those failures. When I first started writing code, I remember banging my head against a wall trying to figure out recursion. This concept was actually a pain for me to learn. I spent countless hours debugging the classic recursive algorithms like Fibonacci and merge sort. I kept it going until it clicked, and when it did, it opened up a whole new world of problem-solving skills on me. It was very useful later on when I did dive into ACM ICPC programming contests. And there I had to solve problems using divide and conquer paradigms which have their roots in the concept of recursion. So my recommendation for you is to find tasks that are just beyond your current capabilities and work on them until you get better. And this is where real progress actually happens. Here's another example. Take the concept of multi-threading and concurrency. It is one thing to read about threads and learn the basic syntax to create and start a thread in Java, for instance, but it is entirely another thing to manage synchronization issues in real-world application. And when you are handling race conditions, deadlock, or trying to optimize thread usage for performance, you will quickly realize that no amount of theory can replace actual practice, because the complexity of coordinating multiple threads in a live system, ensuring that shared resources get access correctly, and avoiding issues like deadlocks or live lock are lessons that can only be learned through hands-on experience. But what is the most effective way to learn? Well, I think one of the best ways we can learn software development is by surrounding ourselves with other developers who know more than us. I'm serious, this is more valuable than any book, tutorial, or online course. I cannot stress this enough. Software development is not an individual endeavor. The best developers are those who are good team players and are constantly learning from others. I have had the privilege of working with some incredible developers, and every single time I learned something new. Whether it was a clever way to refactor code, a shortcut in an IDE, or simply a better understanding of a problem, those interactions shaped me as a developer. And I personally believe that when it comes to learning, there is nothing else like a human-to-human interaction. And I agree, AI is a great tool for learning, but I believe that as humans, we have evolved to learn from other humans in a more effective way. It is like, for me, if someone tells me something directly, then my brain retains that information much better than, for example, if I heard the same thing in a video or just read it somewhere. If you are not already part of a software development community, I recommend you to join one, whether it is a local meetup, an online forum, or even just a small group of friends who code. This will fast track your learning. Like, for example, I try to regularly attend local meetups, hackathons, and conferences, and these events have been game changers for me. Not only do I get to hear from industry leaders who offer fresh perspective on emerging technologies, but I also meet people who come from orthogonal fields like data science, cybersecurity, or even hardware engineers, and they bring new insights that I had never considered. So these meetups and conferences are more than just networking opportunities to me. They are like intellectual gyms where you can flex your mental muscles, exchange ideas, and absorb knowledge that you wouldn't encounter in your everyday work. And this kind of effort pays very well in the long term across many aspects of your life. Let me tell you why. Software development is a skill that doesn't just pay off in a job or career. It changes the way you think. It teaches how to solve problems, how to break down complex ideas into manageable pieces, and how to approach challenges creatively. These are skills that transfer into every aspect of life. And the good thing is that there is no ceiling. From what I have experienced, the more I learn, the more doors opens up for me. Whether you want to build your own applications, create a startup, or just automate tasks at work, software development is a superpower today. Everybody, I believe, should learn how to code. So stick with it, because the long-term reward, both in your career and how you approach the world, is absolutely worth it. So if you are ready to invest the time, the effort, and yes, the patience to put your butt on a chair for hours and hours every single day, then you are on the right track. So don't rush it, because great developers are not born. They are built over time. So what are the takeaways here? First, learning to code is not something you can rush. It is not about mastering a language in 1 week or 2. Instead, it is about a slow, steady skill building towards real expertise. Deliberate practice, working with others, and patience are the real keys to becoming a software developer these days. If you have already gone through it and want to take the next step and start applying for jobs, then you may want to check out this video about how to build a great computer scientist resume. Good luck, and see you in the next one. Bye.